In this section, we're going to determine the formulas for ionic compounds. To do this, we'll need to predict the charges of monatomic and polyatomic ions from the periodic table so we can write proper formulas. Let's begin. Ions are atoms or groups of atoms that have lost electrons to become positive cations or gained electrons to become negative anions. When we're talking about a single atom gaining or losing a charge, this will be a monatomic ion. To help you remember that cations are positive, the internet has produced endless memes, including Pussycat memes, but this one is my favorite. We see that metals tend to give up electrons to form these positive cations, while nonmetals prefer to gain electrons to form anions. When metal cations and nonmetal anions are attracted to one another, a binary ionic compound will form. To determine how many of each ion makes up the compound, we need to determine the charges on each ion. We see that the alkali metals form +1 cations, the alkaline earth metals form +2 cations, then there are 3 metals starting with aluminum's +3, zinc's +2, and silver's +1 charges that we can always count on. Cadmium will also form a +2 cation, but the rest of the transition metals can take on 2 or more different charges depending on the nonmetal they're combining with. The nonmetals also have some predictable charges, starting with the -1 in the halogens, -2 for oxygen, sulfur, and selenium, and -3 for nitrogen and phosphorus. Every other charge will need to be determined from the formula or name of the compound. Binary compounds must combine in ratios that result in an electrically neutral compound overall. For example, a +3 aluminum cation must combine with enough -1 chlorine anions to have an overall 0 charge. We can do this by adding chlorine until the charges cancel out, or we can drop signs, cross charges to get the proper subscripts. If you use the drop signs, cross charges method, just make sure that the compound's formula is the lowest whole number ratio of elements. We can use the same process for aluminum and oxygen. First, we look up the charges until we memorize them to find that aluminum is a +3 cation and oxygen is a -2 anion. If we drop signs, cross charges, we get Al2O3 for an answer. Double checking the charges, we see 2 aluminum +3 ions gives a +6 charge, and 3 O2- ions gives a -6 charge, so +6 - 6 equals 0 overall. Here are 4 examples for you to work through. Pause the video to see if you can come up with the correct formulas. Given a formula, we can apply a simple bit of algebra to determine the charge on an ion. For example, iron forms 2 compounds, FeCl2 and FeCl3. What is the charge on iron in each compound? For FeCl2, we can write this as 1 iron atom times an unknown charge of X plus 2 chlorine atoms times a charge of -1 each. We know the compound must be electrically neutral, so we set this equal to 0. Solving for X, we see iron has a charge of +2. Using the same process for FeCl3, we take 1 iron atom times an unknown charge X plus 3 chlorine ions times a charge of -1 equals 0. Solving for X, we see that iron has a +3 charge in this compound. Here are 2 for you to try. Pause the video and use the same process to determine the charge on copper in the 2 compounds. Polyatomic ions are groups of 2 or more bonded atoms that have lost or gained electrons, resulting in an overall net charge. For example, the carbonate ion, CO3 2-, has 1 carbon atom bonded to 3 oxygen atoms. It's gained 2 electrons for a -2 charge overall. Another example is ammonium, NH4+, which has 1 nitrogen atom, 4 hydrogen atoms, and has lost 1 electron for a +1 charge. Whenever you see a polyatomic ion, keep in mind that they're a package deal. You don't want to break them apart when building formulas. Table 3.2 lists some common polyatomic ions. At a minimum, you'll want to memorize those listed on the Concepts to Memorize handout. We can use the drop signs cross charges method to write formulas of compounds containing polyatomic ions if we're sure to use the least common multiple of the ions to balance the positive and negative charges. If you need more than 1 unit of the polyatomic ion, you'll enclose the polyatomic ion in parentheses and place the subscript outside of the parentheses. For example, calcium and nitrate combine to form CaNO3 2. Double checking our charges, we see that 2 -1 nitrates indeed balance out a +2 calcium ion to give a neutral compound overall. Here are 2 examples for you to try. Pause the video and write the formula for each compound. As always, I'll leave you with the parting thoughts of the authors.